All right, we've been talking about local exhaust ventilation. And again, local exhaust ventilation is where you're sucking up the contaminant at the source. You've got a canopy or some type of hood right there at the point where the contaminant is being generated. In some cases, the system is actually connected to the tool that's sucking up the contaminant. So that's really the gist of local exhaust ventilation. Collect the contaminant at the point where it's generated. Now, dilution ventilation is different. A lot of the same components are used. A lot of the same principles apply to dilution ventilation. But with dilution ventilation, the focus is not on collecting the contaminant at its source. The focus of dilution ventilation is to dilute the contaminants in a work area. In the picture here, we have some tanks and vessels that workers are inside of or getting ready to enter. These are the types of work environments where dilution ventilation would be used. Over on the right, they're getting ready to enter a diesel tank. Before they enter that diesel tank, they need to make sure they've purged that tank. You can see we got diesel oil. Whoops. Get my pen turned on here so I can make some annotations as we move along. And we have diesel oil. And that's another thing worth mentioning. Anytime you have a tank like this, it needs to be marked what is in it or what was in it, because that will determine the safety measures that need to be taken when you enter that space. Again, diesel oil, if they're entering that space, they need to make sure all of the vapors are purged from that space before it's safe to enter. These workers over here getting ready to enter that diesel tank, they've got their respirators on, they've got their Tyvek suits, they are prepared to enter that space. But I don't see any ventilation. I'm not sure those hoses there are ventilation hoses, but they do have openings cut in the tank. Those openings may be sufficient to allow natural air movement to purge the gases from that tank. And we'll talk about natural ventilation as we talk about dilution ventilation. You don't always need fans. You don't always need ductwork or hoses. Sometimes natural ventilation, if it's set up properly, can provide more than adequate ventilation in these types of work settings. But let's go ahead. I've mentioned some of these points already, but let's just go ahead and talk about what we mean by dilution ventilation. We're blowing clean air into a contaminated workspace to lower the concentration of contaminants to a safe level, or to lower the concentration below an explosive level. If we have a gas tank or a diesel tank or a tank that held some other flammable liquid that produces a flammable vapor, one of our goals is to get that concentration below the lower explosive limit. And we'll talk about that in more detail as we go. Another big reason for dilution ventilation is just to maintain the adequate oxygen level in the space. And you've heard me mention it 20 times. In my experience, that's the biggest problem in a lot of confined spaces. Not enough oxygen in the space to support life. So as we go through this topic, we're going to talk about all of these different variations on dilution ventilation. Now, when it comes to a safe level, what do we mean by safe level? Best practice, your safe level is going to be below the action level, which is generally 1/2 of the OSHA 8-hour PAL. Or if you're with a company working TLVs, using TLVs as your standard, then you should shoot for 1/2 of the threshold limit value before you consider it safe for entry, safe for workers to be in that workspace. Dilution ventilation can help us achieve those levels. With dilution ventilation, we can go well below 1/2 of the PAL or 1/2 of the TLV in a lot of cases. Also, if we're talking about flammable vapors or explosive vapors, we want to be below the lower explosive limit. Normally, we want to be well below the lower explosive limit, maybe like 10% of what the LEL value is for the particular substance. Now, dilution ventilation is most appropriate for lower toxicity contaminants at lower concentration levels. If we're in a work environment where we have high toxicity contaminants at high levels, or just we have high toxicity contaminants, or we have high concentration levels, that's probably a situation where we should be using local exhaust ventilation. And local exhaust ventilation sucks the contaminant out at the source where the contaminant is generated. Again, if high toxicity or high concentrations, LEV would be the better option. Dilution ventilation is where it's not quite as hazardous of a situation. When we're using dilution ventilation, one of our first steps is to test the atmosphere to see what our level of contamination is. Then once we get the ventilation system running, we want to test the atmosphere after it's been diluted. And also, best practice, if you have a worker in a workspace where there are contaminants or there's the potential for contaminants, testing should continue throughout the work operations. Wearing a personal air monitor, for example, a personal air monitor that's calibrated for the types of contaminants that are likely to be in that workspace. And that's going back to direct reading instruments. Or you might perform some type of sampling procedure. But sampling procedures tend not to be as good because most sampling procedures you have to involve a laboratory. It's not a real-time readout. The direct reading instruments are best for this continual monitoring throughout a work operation. One term that you're going to hear a lot in our discussion of local exhaust ventilation is mixing. What do we mean by mixing? When mixing occurs, we're mixing clean air with contaminated air. Properly working dilution ventilation systems will mix that air efficiently. And when that air is mixed efficiently, then the contaminated air is going to be diluted. The concentration levels aren't going to be as high. But one problem we see sometimes with dilution ventilation, if it's not set up properly, the dilution air can flow through the space and it doesn't mix with the contaminated air. That's one thing to keep in mind as you're using these ventilation systems. You got to make sure that the clean air, the fresh air, is mixing with the contaminated air and diluting that contaminated air. That's another reason for this continual monitoring throughout the work process. If we continually monitor throughout the work process, we're going to receive a notification through our direct reading instrument that our dilution is not working properly, if that happens to be the case. Okay, let's talk about some advantages and disadvantages of dilution ventilation. One of the advantages with dilution ventilation, it's usually lower equipment and installation costs, less maintenance involved because the systems tend not to be as elaborate. It is effective for controlling small amounts of low toxicity chemicals, and it can be effective for controlling flammable or combustible gases or vapors. The disadvantage, it does not completely remove contaminants. Shouldn't be used with highly toxic chemicals, and it shouldn't be used where there's a high concentration of contaminants. Another disadvantage that affects the operating costs of a dilution ventilation system is it requires a large volume of makeup air. If we are providing our makeup air through mechanical ventilation systems, then that can be more expensive. Now, if we're able to provide the makeup air naturally with natural ventilation, then that's not so much of a problem. Another disadvantage or problem with dilution ventilation is that it's not real good for controlling a surge of a contaminant. It's best to use dilution ventilation when the concentration level is fairly constant throughout the work process. Again, if there's a surge of gases or vapors or other contaminants or other irregular emissions of the contaminants, then it may not be able to handle that surge, that instantaneous high level of concentration. So another thing to keep in mind with dilution ventilation. Okay, we've talked about some of this already, but let's contrast dilution with local exhaust ventilation. And a lot of the same principles of air movement apply. Pressure, velocity, air volume, fan laws, it's all applicable to dilution ventilation systems. That's why this unit won't be as long as the other unit that we just finished up. But speaking of the unit we just finished up, I know that seems like a lot, the modules in that, but that's about the equivalent to 5 regular class periods. When you add up all the minutes of those local exhaust ventilation modules and divide by 50 minutes, which is our normal class period, it works out to like 5 or 6 class periods for local exhaust ventilation, which is about what we would have spent on LEV if we had been in a normal classroom situation. Dilution ventilation, we won't spend quite as much time, quite as many class periods, because we've covered a lot of the basics of ventilation. But let's contrast dilution versus local exhaust. Again, dilution, low toxicity, low generation rate. There's not a specific source of contamination. It may even be a contaminant source that moves around the workspace. With local exhaust, that's best used with high toxicity, high generation rate, where there's a point source that's easily identifiable. In some work environments, you might use elements of both local exhaust and dilution ventilation, depending on the work setting. It's not one, doesn't have to be one or the other. It could be both if both are needed in different work settings. Speaking of work settings, here are some examples, example operations where dilution ventilation could be used. Painting, vehicle repair or maintenance areas, of course welding, repair work inside of a tank, or any kind of operation where you have solvents evaporating into the work atmosphere, whether it's methyl ethyl ketone or acetone or some other cleaning solvent. A lot of these solvents can be toxic, can be problems in the workspace. They need to be at least diluted. In some cases, maybe they even need local exhaust ventilation systems. An example where I've used dilution ventilation and also local exhaust ventilation, but really dilution and ventilation most of the time is going to be adequate inside of an excavation, a shaft, or a caisson where there's an inadequate natural ventilation flow. One of the good things about construction and these types of contaminants that we've been talking about, a lot of construction is outdoors where you have a natural ventilation going on, and that natural ventilation will take care of the problem a lot of the time. But if you're inside of a tank, a shaft, a caisson, an excavation where the air can't move, that's where you may need to use dilution ventilation. If you've got something inside the excavation shaft or caisson that is generating a high volume of contaminant, then you may need to use local exhaust ventilation to suck that contaminant out of there. Generally, any work area where ventilation is inadequate and harmful atmospheres may exist or develop is a candidate for local exhaust ventilation. Again, that's assuming lower toxicity, lower concentrations for local exhaust or for dilution ventilation. All right, I'm going to go ahead and stop this module here. We're at 20 minutes. When we come back in the next module, we're going to talk about using natural ventilation, natural airflow to ventilate our workspaces.